In this law of definite composition, a compound always contain same elements in a constant proportion by mass. For example, water is always 11.2% hydrogen and 88.8% oxygen by mass, no matter what its source. So, composition of that elements in the compound remains constant. Proportions by mass remains constant. Now, a unit of matter composed of two or more non-metal atoms is a molecule, and a chemical formula is an expression of the number of the atoms of each element in a compound. You can see in this example, you can see sulfuric acid H.2SO4, where you can, the formula is H.2SO4, where you can find two number of atoms of hydrogen, one atom of sulfur, and 4 atoms of oxygen. The number of each type of atom in a molecule is indicated by subscript in a chemical formula. If there is only one atom of a certain type, number 1 is used. For example, a molecule of vitamin B3 has 6 carbon atoms, 6 hydrogen atoms, and 2 nitrogen atoms, and 1 oxygen atom. What is the chemical formula? So you can write carbon C 6 H 6 N 2 O. So this is the formula for vitamin B3. Now, how do we interpret chemical formulas? You can see some chemical formulas use parentheses to clarify atomic composition. For example, ethylene glycol, a component of some antifreezes, has a chemical formula of C2H4 in parentheses OH2. That means it contains 2 carbon atoms, 4 hydrogen atoms, and 2 OH unit. So, for a total of 6 hydrogen atoms and 2 oxygen atoms. The question is, how many total atoms in this ethylene glycol? So when you calculate all of them, carbon is 2, hydrogen is 4 plus 2, which is 6, and oxygen is 2. So total number of atoms are 10, because 2 plus 6 plus 2, which is 10. Okay. Now we are going to discuss about physical property and chemical property. A physical property is a characteristic of pure substance that we can observe without changing its composition. Physical properties include appearance, melting points, boiling points, density, heat, electrical conductivity, solubility, and physical state. You can see all these properties you can observe without changing its composition. While chemical property of a pure substance describes its chemical reactions with other substance. So it describes some reactivity with other substance, how it reacts with other substance. That's a chemical property. Now let's take an example of chemical property. You can see sodium metal in this watch glass. When you see in the microscope in the micro level, this blue color round balls are sodium atoms, and this is chlorine gas. This gas, when you see in micro level, you can see chlorine Cl2 green color bimolecular atoms. When they react, it produces table salt, and you can see the structure of table salt. So you can see before their compositions of sodium and chlorine are different, and after they produce NaCl, their composition change. So that's called chemical properties. Now we are going to discuss about physical change and chemical change. Physical change is a change where chemical composition of a substance does not change. This including shape, physical state of a pure substance. Chemical change is a chemical reaction. in the composition of a sample changes during chemical change. Now, what are the evidence for chemical changes? When you see gas bubbles, gas release during chemical reactions, during reaction, light or heat release, or change color permanently. These are called evidence for chemical reactions. That's where you can tell that chemical reaction occurs. So we'll talk about law of conservation of mass in next slide.